cat interviews at Uber, Confluent, Indeed, and many more companies. I've seen it all. After countless hours on the other side of the table, I know exactly what top companies are looking for, especially in LLD. In this course, I'll share the insider blueprints, what to focus on, especially key design patterns, how much multi-threading, very important, counter question, traps, and how to tackle them confidently. This course is structured, practical, and tailored on what companies are looking for right now. Let's get you interview ready right now. Okay, so after seeing observer, next move on to the iterator design pattern. Obviously, iterator design pattern is mostly to traverse onto any collection of objects, for example, arrays, list, literally anything. And the best part is it doesn't expose the underlying implementation because see, if you must have seen that, let's compare different languages now, then we'll compare in the same language different functions. So in different languages to iterate on anything, right? We have, let's say in C++, we can simply iterate on, let's say, vector of I. But in Java, we have to do, array list of dot get I. And again, different implementation for set, and map, all that is different. But just imagine that you just have to call next. It doesn't matter if there is exist or not. You don't have to check the size condition. You don't have to check, if it is dot I, get I, maybe anything. Just call next, and it will be available to you. Just one thing. It will simplify. And again, you don't have to worry about the underlying implementation, and that is what iterator pattern gives us. Just beauty of next and has next, and that's the thing. Again, as I said, arrays, sets, map, linked list, like there can be literally so many data structures that you can iterate on, but you just have to look for next and has next. So it's extremely useful whenever you have to iterate on the elements in a collection. Now it can be literally any collection, and the best part is that it doesn't expose the internal complexity of iteration in the data structure. For example, let's take a real life example: playlist iterator, which will help. Again, why playlist iterator? Because this is one of the most used cased real life example. For example, you are building any music app, for example, YouTube Music, Apple Music, Spotify, all that. So you have different, like you will give your users different ways to iterate on the playlist. It can be a random shuffle, like just giving, you must have seen that there's a random shuffle, which helps you to shuffle the songs randomly and just give you songs. They can be something, okay, like skipping those songs one at a time, just maybe playing in reverse. So there can be multiple ways how I can iterate on a list of songs which I have in my collection. It can be a favorite collection as well, which means I can ask, okay, out of this list of collection of songs, give me my list of collection of songs. Out of that list, give me my favorite list of collection of songs. So there can be literally multiple ways. Now, obviously, as we saw that why it is named iterator, it is because it iterates over the collection of elements. Now, let's see an example with a traditional way. In a traditional way, if I ask you to play some songs, you will have simple implementation. Okay, iterate on the songs and then simply some implementation of playing. Now, this is just one way of just playing, just, very simple naive iteration logic. As in, very simple naive skimming through all of the elements. But if I ask you that, okay, please add logic of random, please add logic of shuffle, please add logic of skipping, please add logic of reverse, then you will end up having if else, if else, if else, if else, and every time you will end up modifying this playlist, which is obviously wrong, right? So again, as we saw, that it's hard to maintain. It's very tightly coupled with the existing playlist logic. Every time I have to change the playlist and all that stuff, that's very hard. And again, obviously, whenever things are very tightly coupled and not maintainable, they are very hard to scale as well. So how do we go about it? Obviously, we saw that one of the biggest issue will be that if I give a simple shuffle, then okay, you'll have to add some if else condition. And again, this is just one change, and you end up changing your playlist, which is kind of unnecessary, right? That's the thing. What you will do, obviously, you have to simply figure out a way that how I can end up catering different kind of iteration to the playlist. I can have a normal order, I can have a random order, I can have a favorite order, just iterating on the favorite. So to go about this, we will have a playlist iterator interface. This will have a simple two methods, next and has next. This will say, okay, I'll just simply check, do I have a next? Do I have next song? Now, it can be literally my favorite iterator as well, which means if I call my next internally, again, I don't care. I don't care internally how I implemented my favorite playlist iterator. But if I call its next, then it will help me to know that do I have a next there or not? Do I have next favorite song or not? And has next will next will give me the actual next song, and has next will check do I have that next favorite song or not. Again, if it's a shuffle, it will give me a shuffled song, next song. Let's see how the concrete implementation will look like. Let's say take a simple place iterator. Very simple. I will have simple initialize and we'll say, okay, start off from the very starting index. Then I'll have to override these two specific methods. One is has next, where I'll check, okay, if the index has not passed my playlist songs. Again, you see that here I have specific implementation for a simple place iterator, and that is only specific for this iterator. And again, has next will check, can I go next or not? Next will check, can I going next, and has next will check, can I go next or not? So same way, if I want to shuffle, so shuffle place iterator will say that bro, simply do a shuffle. And then now I can simply check has next and simply iterate on the next one. Same way, I can have favorite place iterator. This will simply check that, oh, give me a first favorite song. And again, if I find it, I'll just simply have it. Okay, I have the next favorite song, and then simply give that favorite song. So you see that next time in future, if anyone asks me some random requirement, my new year favorite song, or my March favorite song, so I don't need to have any if else condition. I can make a specific March favorite song iterator, a March playlist iterator, and I can have an individual logic of the same. Now, how I will club this logic onto my function? Obviously, I will say, okay, in my playlist, I will have a simple case that, with a specific type, just define the corresponding iterator and passing in the current object. Again, obviously, playlist one. Again, all these things we have covered in the oops lecture. So if you haven't watched it, make sure that you watch oops first and then come back here if you don't know about this. But yeah, now you see that with this simple iterator for a specific type, I have got the correct iterator. Let's say if the person asks for favorite songs, so I'll give him the favorite iterator. Now, when I have the favorite iterator, then I can simply work on it. So let's see how. So firstly, in my playlist, which is this one playlist, I simply added a couple of songs. Okay, I added a couple of songs, and it's a simple simple array list in which I added some songs. Again, you can have a song object as well, totally up to you. But again, just for simplicity, just to showcase the iterator, I skipped that thing. Now, obviously, I will have a playlist iterator, which is a simple iterator. Again, I called my playlist, call the iterator, and give him a simple. So what will happen? It will go and call a new simple playlist iterator with current object. So this playlist object is being passed. Like when it will return this iterator, this simple iterator is on this playlist object. Again, this entire concept is because of this keyword. Coming on back, now this playlist iterator, this simple iterator will simply iterate on this playlist songs. So again, I'll simply check a has next and I'll simply iterate on them. Same way, if I want to have a shuffle iterator, do the same thing. Favorite iterator, do the same thing. And that's how I have decoupled a lot of things. So the output will be like that, all this stuff will be corresponding output, and anytime next time in future I want to have any other implementation, I can have a new implementation. Let's, as I said, March playlist iterator, or maybe new year end playlist iterator, like this. Anything can be there, and that is something which will be plug and play. Okay, just take this, and then next person asks me about March playlist, I'll simply return him this specific iterator. So what you saw, that firstly, it has a lot of flexibility, as we have been seeing in literally all of the observer design pattern questions. Separation of concerns, because now things are separate and not dependent upon each other. Scalability is obviously insane. And again, we also saw that in Java, literally we have iterator itself already. And that's the beauty of Java, right? Like you have array list, you have hash set, you have hash map. All these collections will have their corresponding own iterator. And again, we have next and has next. Obviously, we have the remove and stuff. But again, the best part is that if you have any of the collection array list, okay, fruits. So I just simply call fruits iterator. Now this iterator which I have returned, this iterator can simply iterate on my any data structure which I have. So in this case, array list, I can simply iterate on this collection and say, okay, while my iterator dot has next, simply print out things, which means print out the next element. So that is how you can simply iterate. That is how you can simply iterate on your any data structure or any collection, I should say, in Java. And that's the beauty of Java. That, like, Java is simply God. So yeah, that's the entire thing. Lastly, as we mentioned, some of the real life use cases is simply whenever you want to iterate on anything. It can be your database records, it can be your any game object, it can be your music playlist, anything whatsoever. And the best part is it gives you clean, scalable, flexible, and maintainable piece of code which effectively manages collection. And again, the best part is it doesn't clutter the logic and keeps all the iteration logic of different iterator patterns kind of different. And that's how the specific iteration strategies are always kept different, not clubbing with each other. And again, as we said, it makes your code much more easy to grow and scale. And obviously I can obviously add any new features to just add any collections in future, or any iteration or accessing strategies in future, I can simply add on top of it. That's how your simple iterator pattern works. And as I mentioned, this question was, again, if you see my Coinbase interview experience, I've already mentioned that this is a very, very, very frequently asked question in Coinbase. So yeah, make sure that you check it out. Bye bye, take care. Let's hit the light target of 2 clicks and see you next time. Goodbye, take care. Bye bye.